So guys, we're in Ren Lake College in southern Illinois. We're looking at some plots that we did jointly with Syngenta on some fungicide and nutritional combinations. Wanted to walk through some of the findings that we had this year. This year in 2023 in southern Illinois, we had a very stressful year. An extended period of really hot, dry weather, and then we've received some rains really late this month of August. But I want to show you the impact of environmental stresses have on a crop and what we can do to manage through those stresses with some of the trials that we did. So if you look here, we've got a couple ears that we just randomly pulled out, and you can tell that this crop was really stressed when the year started off, right from the get-go. So between V3 and V5, we were bone dry down here, and it was starting to warm up, and we didn't set very many kernels around. We've got 12 kernels around on the untreated, and obviously you can see ovule development length of ear was not significant either. So a lot of stress happened onto this. So this is untreated plot right here. Next we go to our architecture phase and our architecture application. In this application, we ran a quart of Architect, we ran a quart of XR5 sulfur, and then we also ran Mitigation Neo with it. And we wanted to demonstrate what that combination will do to help facilitate this crop and manage it through a stressful period. And this is what we found. So in this particular plot, we bumped up to 14 to 16 around pretty consistently. I do have an ear that I pulled off that was 18 around in this one, but this is pretty average, right? So we had a better kernel set between that V3 and V5 time frame, and also ovule development, that length of ear. Now you can tell this was just the architecture application. You can tell that this crop still had stresses after that. And what I mean by that is it had some late season stresses that caused a lot of this tip back. So the next one that we're going to go to is the architecture application plus an R1 application, so that reproduction time frame with Trivapro application. So I'm going to find my ears here. So as you can see on this particular ear, you know, we've got nice kernel set, we've got good ovule development, but one thing that we noticed was a lot less tip back. We still have some tip back because it's just been so doggone stressful this year, this growing season. But we've reduced that substantially, and we've set another 2 to 3 kernels around for the length of that ear, which, guys, equates into yield. The other thing that we've noticed with the joint application, the first one followed by the second, is that the kernel depth. We have a deeper kernel that should result in yield and test weight. So again, this is 2 applications. This is the architecture application with Architect, XR5 sulfur, and Mitigation Neo, followed by we had Trivapro, Octane, XR5 boron, and OnWard Max on this application. So on that OnWard Max did a really nice job of helping that Trivapro reduce that stress and allow that plant to physically fill more of the tip out. So the next application is just the reproduction time frame. So I've got a set of ears right here that show both applications to just a late season application. And you can see that trying to just do that late season application and recapture what's already been lost, we still fill the ear out, do a little bit better job at filling the ear out, but you can't go back in time and set the number of kernels around. So we consistently have 2 to 4 more kernels around on every ear, where we had the architecture application followed by the reproduction versus just the reproduction. Reproduction definitely paid, right? It helped this kernel this ear from aborting kernels and helping it fill out. But significant difference when you think about running a program, doing an architecture followed by reproduction versus just doing reproduction. Down here I've got one last check to walk you to, and I'll show you the value of just the reproduction time frame. So this is another untreated check, and this year when it was pollinating, got really hot and really stressed, right? And part of OnWard Max, what it has is a combination of late season PGRs to help drive down that stress, keep that pollen viable, and allow that plant to pollinate and fill out the kernels. And what you'll notice here, This is a pretty average year from this particular one. A lot of skips, guys. So right, this is all about pollen viability and reproduction plant health with OnWard Max. And this did not have OnWard Max, and you can tell it. So farmers gonna be pretty disappointed if they didn't do a late season application. So that's what I got for today. It's pretty interesting what we're finding out here in Southern Illinois. Thanks.